In this video, we will compare and contrast unconstrained versus constrained optimization. Once the behavior of the dataset is known, it is very important to understand how the other requirements the solution must uphold and maintain have an effect on the formulation of the solution. To understand the principle of constraints, let us look at the functions f of x equals x squared minus 5x plus 6, and f of x equals negative x squared plus 5x minus 6. For x squared minus 5x plus 6, the minimum is minus 0.25, and for negative x squared plus 5x minus 6, the maximum is 0.25. But, let us say that our solution is subject to some additional rules or allowances that the original function, otherwise known as the objective function, does not account for. To ensure these allowances are acknowledged, limiting factors, or constraints, are applied to the objective function. Constraints can come in many ways, shapes, and forms. As seen previously, they can come in the form of a value or function limiting the possible solution set. This type of constraint is called a linear constraint. However, constraints can also be used to account for complex relationships between various variables that are related to the objective function. An example of these complex relationships could be a nonlinear constraint, where each constraint is a function of more than one variable. Another example of these complex relationships is convex constraints, which is where the constraint is represented by a function that can have a chord line drawn from one end to another, and that line would never be below the original function. Finally, other examples of these complex relationships come based on the objective function, in terms of whether it is continuous and differentiable, or not. Now that the different ways constraints can be used have been discussed, let us discuss when you would use unconstrained optimization. First, before you can apply any constraints to an objective function, you need to make sure that these constraints would actually work for the function. Therefore, people often run the objective function without any constraints to get an idea of the solution space first to make sure the constraints work. Secondly, constrained optimization sets can be replaced by a set of penalty terms acting on the objective function in order to limit the solution behaviors that the constraints would have. Thank you for watching this video. See you in the next video.